welcome back again to the channel. On this video we're gonna discuss the following problem. So we have a big square of length 6, of side length 6, and then inside it we have two blue squares and two red squares, and we are assuming that squares of the same color are of the same size, and we would like to compute the total area of the shaded region, which is the total area of the two blue squares and the two red squares. So as usual, before we discuss the problem together, please give it a try, and you may pause the video right now. Alright, let's get started. First, I'm gonna make a line connecting these two sides. Okay, so notice that the dashed line, this line, is having the same length as the side of the square. So it means that the dashed line length is also 6 as well. And that tells us that half of the length of the dashed line, which is the diagonal of the blue square, is equal to 3. Okay, so we know that this is 3. The diagonal of the blue square is 3. Okay, now remember that if we have a square of side length A, right, then the diagonal is 8 times square root of 2. So then we have 8 times square root of 2 is equal to 3. Or A is nothing but 3 over square root of 2. Since we know the side length of the square, which is 3 over square root of 2, then we can compute its area. So the total area of the blue squares, so the total area of blue squares is twice of A squared, twice of 3 over square root of 2 squared. Now the square of 3 over square root of 2 is 9 over 2. So times 2, we get 9. Right. Now we need to find the length side of the red square. So to do so, let's connect the center of the big square to the left corner of the big square. Okay. Now notice that this dashed line divided the blue square into two equal parts. Since this angle is a 90-degree angle, so therefore we know that this one is 45 degree. So this is 45. Okay. And since the dashed line, this line and this side of the square is parallel to each other, so therefore this angle is equal to that angle. So let me indicate it by drawing in this way. So that's also 45-degree angle, right? And now this angle is a 90-degree angle because this side of the square is perpendicular to the side of the bigger square. So if this one is a perpendicular angle, is a 90-degree angle, then this must be also 45 degree, right? Since this one and that one are 45 degree, then this triangle is an isosceles triangle where the legs are this segment and that segment. So then the leg must have equal length. So let us indicate the length by writing in this way. So that segment is of equal length to that segment, right? But this one is the side, one of the side of the square. So this side must also have equal length. So that's the same, and by similar argument, this guy is also of the same length. That tells us that the length of the big square is divided into 3 equal parts, which is 2 for each part. So it means that the side length of the red square is equal to 2. So then the total area of the red squares is equal to twice of 2 squared, which is 8. So then if we add them all, then the total shaded region is equal to 9 plus 8, which is 17. And that's all. So thank you very much for watching. See you again on the next